Okay, geometry students, in this video today, we are going to be studying circles and their equations, okay? More than likely, you did not cover this in Algebra 1. Possibly it was covered in Algebra 2. But we're going to go ahead and look at this topic here today. So obviously your heading for today will be equations of circles, okay? Lesson 10.7 is the lesson for today. And be sure and include today's date, okay? Let me fix that real quick. Be sure and include today's date, alright? So that your notes are organized. Equations of circles, lesson 10.7. Let's go ahead and start off by looking at the standard equation of a circle. You will want to write this model down. It's very important that you know this, memorize it, and are able to use it. Here's the model. X minus h quantity squared plus y minus k quantity squared equals r squared. Please copy that down. I'll pause here just a second while you copy that down. X minus h squared plus y minus k squared equals r squared. Now, let me explain what this equation means, alright? In your notes, I want you to go ahead and draw this circle and label this point to -4. Alright, please do that. And then go ahead and draw a radius, and we're going to label that a measurement of 3 units. Go ahead and draw a circle in your notes. Pretend the circle is on the coordinate plane, and pretend the circle is right, the center of the circle is right at 2, -4 right here on the coordinate plane, okay? And then the length of the radius is 3. Now, let's come back up here real quick, students. The center of the circle, please make note of this. The center of the circle is always going to be h, comma, k. Got it? The radius of the circle, please write this down. The radius of the circle will always be r. So as I look at this model, because there's a negative sign here and a negative sign here, you've got to be really careful with your center. And I'm going to talk to you about that later, okay? But right now, all I want you to write down is that your center of the circle, when you're given an equation like this, the center of the circle is always going to be h, k. So these numbers here are going to influence the center of the circle. Got it? Your radius is always r. So see this letter r right here. If you have a power of 2 right here, and you're like, well, Mr. Earhart, what if you don't have a power of 2? We'll get to that later, okay? Just right now, make note that the radius is always this number here squared. So, for example, if I had 5 squared, then the radius would not be 5 squared. The radius would just be 5. Got it? So the right side should have a number squared, and that number that's being squared is always your radius. Makes sense? Alright, now let's go ahead and take a look at this problem here, okay? Notice here the center is 2, -k. Excuse me, 2, -4. So here's how this would look if you had the equation, and I would definitely write this down. It would be x. Now watch carefully, because there's a negative sign here. You always change the sign of this number. This is a positive 2, so you're going to put -2. See how easy that is? This is x, so the 2 goes in the x parentheses right here for h. Alright? This is your y. Whatever this number is, change the sign. Well, next in your model comes what? A power of 2. What comes next? A plus sign. What comes next? A parentheses. Then a y. And then stop. Now here's your k value right here. Because there's a negative sign here, always change the sign of this when you put it into the equation. So because this is a -4, you would put a positive 4. Okay? And then next comes your squared. Then next comes your equal sign. Then your radius, which is 3. And then the squared. There you go. So this circle here, if you wrote the equation of this circle, would look like this. Now, let's take this another direction for a second, okay? Let's do this. What if I gave you this equation here, and I said to graph the circle? Well, look, right away you should know the center of the circle, should you not? Sure you should. You know that this number here and this number here help you so put a positive 2 here. I have a positive 4 here, so put a negative 4 here. There, you just found the center. What if I asked you to tell me the radius? Well, you look to the right side. Is this number written with a power of 2? Yes, it is. So the radius is simply 3. Isn't that easy, guys? Change the signs of this number, and the radius is always this number over here, as long as there's a power of 2. Now, what if there's not a power of 2? Well, let's talk about that. Excuse me, sorry. Let's say we had x minus 2 quantity squared plus y plus 4 quantity squared. And then we had a 16 over here, okay? Well, can we write 16 so that it has a power of 2? Well, sure we can. What does 16 equal? 16 equals what? 4 squared, correct? Sure. So in place of 16, you would simply write 4 squared. And now what's the radius going to be? 4. Okay, now you're probably saying, sorry guys, excuse me again. Sorry, you're probably saying, well, Mr. Eric, that's a really nice, easy problem there. You had 16. 16 is really easy to write with a power of 2. And I would say you're correct. So what if we had a number here like 7? How would you write that with a power of 2? Please take some really good notes on this. Remember, anytime you take the square root of a number and you square it, it equals just that number. So let's apply that to this. If you can't write this number with a power of 2, then write it like this. Watch this. Doesn't 7 equal this? Look at it. Think about it. You're squaring the square root of 7, so you get 7. So for 7 right here, I would just rewrite the 7 like this. That's totally legal. The square of the square root of 7 equals 7. So now, square root of 7 squared, what's my radius? Well, the number being squared is square root of 7, so there's my radius. My radius is square root of 7. So hopefully you can apply that to just about any situation there in case there's any questions on that. If you had, you might have a number there like 50, Well, if you had 50, then just put a square root around it and square it like that. And there you go. If you had a number there like 25, well, you can make that a perfect square. Just put 5 squared. Okay, all right, let's continue on. Now, let's take a look at 3 problems. 2 are pretty easy, and then 1 is pretty challenging. In fact, the 1 is very, very challenging. Okay, let's go quickly through the first 2 problems. Here's the first problem. Please copy this down. I'll wait about 30 seconds while you copy this down. Write the standard form of the circle that has a center at 3, -1, and a radius of 4. Okay, here we go. Anytime from now on the rest of the year, I ask you to write the equation of a circle. You need 2 things. Always find these 2 things. Find the center and find the radius. Once you find those 2 things, you're good. Now, what makes this problem so simple is I've given you the center and I've given you the radius. I won't always do that, as you're about ready to see in the next 2 problems after this. But anytime I ask you to write the standard form of a circle or the equation of a circle, you want to find these 2 things. Once you have these 2 things, it's so easy. X, change the sign of the 3, quantity squared, plus y, change the sign of the y, equals, take your radius and square it. Now, I don't care on a test or a quiz if you put 4 squared or if you put 16. I don't care which one of these 2 you put. It doesn't matter to me, okay? But there we go, we're finished. Moving on to the next problem. It's that easy. So if I ask you to write the equation of a circle, you need 2 things, center and radius. Alright, next problem. Please copy this in your notes. The point 1, 2 is on a circle, and the center is 0, 0. Write the equation of the circle. Please copy that down in your notes. Alright, and here we go. Now, I just told you about 60 seconds ago, from now on, when I I ask you to write the equation of a circle, you need what two things? The center and the radius. Well, they gave us the center, 0, 0, so we're good there. But the radius we don't have. So let's think about this for a second, students. You're smart students, you can figure this out. Here's the center, 0, 0, okay? And then a point on the circle is 1, 2, okay? So how would I find the distance from here to here? Well, hopefully some of you know this, okay? If I was there in class, I would call on someone and see if they knew the answer. I mean, the distance from here to here, we're just going to use the good old distance formula. And that's one of the reasons we've learned this. We learned this months and months and months ago. Remember, the distance formula is x minus x, quantity squared, plus y minus y, quantity squared. That's the distance formula. Okay? And what the distance formula does for you is it allows you to find the distance between 2 points. So if this is truly the center, which it is, and if this point lies on the circle, which it does, then I can find the distance between these 2 points, and that will be my radius. Alright? So here we go. Square root of 0. This is my x, this is my y, this is my x, this is my y. 0 minus 1, quantity squared, plus 0 minus 2, quantity squared. Okay? Well, this is pretty simple. 0 minus 1 is negative 1. Negative 1 times negative 1 is 1. Let's go over that again. 0 minus 1 is negative 1. Negative 1 squared is negative 1 times negative 1. That's positive 1. 0 minus 2 is negative 2. Negative 2 squared is negative 2 times negative 2. That's a positive 4. So the radius would be the square root of 5. There we go. 1 plus 4 is 5. So now very quickly I can write my equation. Here it is. It is x minus 0. Change the sign of the 0. By the way, if you put plus 0, it doesn't matter because we're dealing with 0, so either way is fine. Quantity squared plus y minus 0, quantity squared, equals square root of 5 squared. Now square root of 5 squared is just 5. I don't care if you put square root of 5 squared or just 5, it doesn't matter to me. But I'd like to show you something here, students. X minus 0 is just x, and y minus 0 is just y. So really you have this. X squared plus y squared equals square root of 5 squared. Now again, I don't care. You're welcome to write this for your answer. That does not bother me one bit. This would also be acceptable too. Okay? Alright, now on to the really, really, really difficult problem. Please take some really good notes, alright? I'm going to give you 3 points that lie on a circle, okay? And I want you to write the equation. It's going to be really hard to do, okay? We're going to get a picture of this. We're going to take this step by step by step. This problem will probably take about 10 minutes, alright? Find the equation of the circle that passes through these 3 points. Now, you do not need to graph it usually, but in this case here, I'm going to ask you to graph it because I want you to see what we're doing. So my advice to you is to graph these 3 points, okay? You can take or leave my advice, that's up to you, but I would strongly recommend that you plot these points. And so here we go. Alright, let's use black for these points. Negative 1, 5 would be here. 7, 1 would be here. And 5, negative 3. Now, first of all, Mr. Arrow, how do we know for sure this circle exists? Well, guys, look. Through any 3 non-collinear points, a circle always exists. Always. Now, if these 3 points line up in a straight line, thus they're collinear, then we don't know for sure that we cannot draw a circle that passes through all 3 points. But if you have 3 non-collinear points, a circle always exists. Now, are you listening to me? Here's the key. The key is to find a point. I'm going to change colors. The key is to find a point that is the same distance from all 3 points. Because if I can find a point right there, let's pretend, don't write that down, just listen. Let's pretend that's the circle. If I can find a point that is the same distance from all 3 of those points, then I've got my radius, and then I can sketch my circle. And even someone like me, who's extremely drawing challenged, as you can tell, can draw, well, I guess I can't draw a circle. I can't even do that, but anyways, you get the point. What I'm trying to say to you is this. if you have three non-collinear points, you have to find the point that's equidistant from those points. Got it? Now here's how we're going to do this. Take some really good notes. Okay? First of all, even though we're drawing a circle, go ahead and sketch a little triangle here. Alright? That's the first thing we're going to do. Mr. Harris, why would you do that? Well, I'm glad you asked. Here's why. We learned months and months ago. Are you ready for this? This is so cool. That if you find the perpendicular bisector of the three sides, the point where they intersect is equidistant from the endpoints. We learned that. We had all these different names, and actually, as your teacher, I should have these names memorized, and I don't. I wish that I did. I forget what it's called, but I'll try to look it up while I'm talking here. But we learned that there is, if you find the three perpendicular bisectors of each side, wherever they intersect, that is a point that is equidistant from the vertices of the triangle. So what we're going to do is we're going to try to find the perpendicular bisector of each side. Okay. Now, first of all, we can go with different sides. It really doesn't matter which one that we do. But here's what we're going to do. We're going to start out by finding the perpendicular bisector of this side here. Okay, so here we go. The midpoint is about right here, and here's the midpoint formula. Remember, it's x plus x. X plus x divided by 2, comma, y plus y divided by 2. So this point here is negative 1, 5. This point here is 7, 1. And this point here is 5, negative 3. Got it? Now, if I want to find the midpoint between these 2 points here, then I take these 2 points here, and here, and I use this formula. Add your 2x's divided by 2, add your 2y's divided by 2. Students, you're in track 1 geometry. I'm not going to do that work for you. I will just tell you what you will get. Alright, the midpoint of this segment right here is going to be 3, 3. So write that down, please. If you use this formula here, you would get the midpoint. Got it? Now I'd like to show you something else. The midpoint of this side over here, I'm just kind of estimating where it is. It looks like it's about right here. If you use this formula here, right here, and use this point and found the midpoint, you will get this right here. You would get 6, negative 1. Let's see. No, I'm incorrect. Sorry about that. It would be right here. It would be this point. We're going to find the midpoint of this segment over here. I have this done already, and so I want to stick to what I've done. So the midpoint of this side right here would be 6, negative 1. All right. So far so good. Not a big deal. We found the midpoint of this side here, and we found the midpoint of this side here. Okay. So let's change those colors. Now, next, we're finding not only the bisector, but the perpendicular bisector. This is a really tough problem. Please stay with me, students. Please stay with me. I now want to find the slope of this line here. So make note of that in your notes. Why, Mr. Aaron? I'm going to tell you why in just a second, okay? So I'm going to put m right here. M equals. Alright? And now, if you were to find the slope of this line here, remember how to find the slope, guys. It's y minus y over x minus x. Please make note of that in your notes, okay? You need to know that. Again, I'm not going to do the work for you. You're in track 1. You guys can take a calculator and take y minus y, get a number, x minus x, get a number, and that's the slope. So if you take this point here and this point here and use the slope formula, here is the slope that you will get out for, sorry guys, my pen is really struggling again today. I've got to get this fixed. You will get this for your slope. You will get negative 1/2. So please write that down. So the slope of this line right here is negative 1/2. Got it? Now let's find the slope of this line. You can work ahead or just wait for me. That's up to you, okay? The slope of this line. Well, you would use these 2 points here and use your formula right here. And the slope of that green line would be this right here. You would get, let me do this real quick in my head here. reciprocal slopes, okay? So what that means is if I draw the perpendicular bisector of this side here, the slope of this line right here would be the negative reciprocal of this slope here, because this line here and this line here are perpendicular. And if they're truly perpendicular, then their slopes have to be negative reciprocals or opposite reciprocal slopes. Now, same thing here. If I draw the perpendicular bisector of this line here, okay, the slope of this green line here would be the negative reciprocal of this slope here, because perpendicular lines have negative reciprocal slopes. So that's why I have found these slopes. So students, let's quickly review, just like in 10 seconds, let's review. I had to find the midpoint of this side, and I did it. I had to find the midpoint here, and I did it. Then I had to find the slope of this line, slope of this line. Now, Mr. Error, why are you not doing all three sides? We really don't need to. If we have two lines that intersect, we know the third line would also intersect at the same point. They have to. So we're just going to go with two sides. Now, why have I done all of this? Because I want to find the equation of the line of this perpendicular bisector right here. I want to find the equation of this line. And I want to find the equation of this line here also. Alright? Of this perpendicular bisector. Now it looks like they're intersecting about right there. Okay? But still I want to make sure. So I'm going to find the equation of this line right here. This green line. Now, I know a point on this line is 3, 3. A point on this line is 3, 3, correct? I also know the slope of this green line. The slope of this green line is the negative reciprocal of this slope here. So I have negative 1/2. Change the sign, it's positive. Flip the 1/2 and you get 2. So I can very quickly write the linear equation for this. Y equals mx plus b. Y is 3. M is 2. X is 3. So 3 equals 6 plus b. Bring the 6 over, make it negative. Negative 3 equals b. So, in red, I'm going to write the linear equation. The slope is 2. B is negative 3. So, the equation is y equals 2x minus 3. There we go. So there's the equation for this green line. Not too bad. Now, let's do the same thing, Mr. Error. Why are we finding these equations? I promise you, I will show you in a second, and it's going to make total sense when I show you, okay? So again, let's review, because you're going to have one of these in your homework, only one, but you're going to have one. Find the midpoint of one side, find the midpoint of the other side, then find the slope of this side, find the slope of this side, then write the linear equations for your two perpendicular bisectors. So, for this perpendicular bisector here, this red one right here, for that one, we know a point that falls on the line, 6, negative 1. And we also know the slope of this line right here. We do, yeah, it's the negative reciprocal of this slope here, because the slope of this line here is 2. So, if you take 2 and you change the sign, you're going to get negative, and if you flip it, you'll get 1/2. So the slope is negative 1/2. So now I'm ready to write my linear equation. Y, or find my linear equation, equals mx plus b. Where the y is, I will put negative 1. Where the slope is, I will put negative 1/2. Where x is, I will put 6, and then plus b. Negative 1/2 times 6 is negative 3, so negative 1 equals negative 3 plus b. Bring the negative 3 over and make it a positive 3. That leaves you with 2 equals b. So I know what the slope is. I know what b is. I am ready to write my linear equation for this green line right here. I'm going to put it right here. Y equals negative 1/2 x. I'm going to move that over, get a little more space. Y equals negative 1/2 x plus 2 is the linear equation of that green line. Now, I told you later I would tell you why I had to find those linear equations. equations. Before I do that for the third time during this problem, I want to review again. If I give you a problem like this in a test or a quiz, and I probably will, by the way, you first of all find the midpoint of one side of the triangle, find the midpoint of another side, then find the slope of one side, then find the slope of one side, then find the linear equations of your two perpendicular bisectors. Now, why'd I do that? Because, students, I have to know where these two lines intersect. Well, Mr. O'Hara's going to look on the graph and see. You can't just use the naked eye to see where that point is. What if it's 1.8? What if it's 2.1? You can't just look at the graph and tell where these two green lines intersect. So we have to take these two equations and solve them to find their point of intersection. So here's what we do. We take these two equations, y equals negative 1/2 plus 2, and the other equation, y equals 2x minus 3, and we put them together and we solve them. Remember, what is y equal? 2x minus 3. So I can pick this up and I can put it in for the y up here because y equals this, so put it in place of y. So I have 2x minus 3 equals negative 1/2 x plus 2. Now get all of your x's on one side, bring the negative 1/2 x over, and it becomes a positive 1/2 x. So I'm left with 2.5 x. 2 plus 1/2 is 2.5. Bring your 3 over and make it a positive 3. So you're left with a 5 right here. Alright, so we have 2.5 x equals 5. Now I know this looks a little messy, but it's really not. 2.5 is the same thing as 2.5, right? So with a calculator, divide both sides by 2.5. And again, my pen is messing up, so hold on one second. And here we go. So divide both sides by 2.5. Well, students, if you take 5 and divide it by 2.5, you get 2. So we got a whole number out. So if x is 2, now come back right up here, see my pen, and put 2 right there. 2 times 2 is 4. 4 minus 3 is 1, so y is 1. So your ordered pair, your point of intersection, is 2, 1. For the fourth time, let's review. Find the midpoint of one side of the triangle. Find the midpoint of another side. Next, find the slope of this side. Find the slope of this side. Next, write the linear equations of your two perpendicular bisectors. And then lastly, see where the 2 lines intersect. And that's the center. You just found the center of your circle. This point right here is supposedly equidistant from this point here, and this point here. So if it is, that's the center of your circle. We just found the point that's equidistant from all 3 points in the triangle. So you just found the center of your circle. Let's put it right up here in your notes. Center equals 2, 1. All right. Now, students, think how quick we are. Think how close we are to finishing now, guys. Think about this problem way back here when I gave you a point on the circle and the center. Remember that? All you had to do was use the distance formula to find the radius, right? Well, look, we know the center. We know a point on the circle. We know 3 points on the circle. 1, 2, 3. Which one do you use? It doesn't matter. I'm going to use 7, 1 just because I feel like it. So, if I find the distance from this point to this point, that's the radius, and I'm finally done. All right. So let's go ahead and use the distance formula and find the distance of that blue line right there. So students, here we go. Let's see here. Get rid of that real quick. There we go. Now, so let's find the distance here. This point right here is 2, 1, and this point right here is 7, 1. Let's find the distance, all right? Distance formula. So here's the distance formula. X minus x, that would be 2 minus 7, quantity squared. X minus x plus y minus y. Here's your y. Here's your y. 1 minus 1, quantity squared. So I end up with 2 minus 7 is 5. 5 squared is 25. 1 minus 1 is 0. 0 squared is 0. So 25 plus 0 is 25. And the square root of 25 is 5. The square root of 25 is 5. So my radius is 5. So I found the center. I found the radius. Here's my equation. I'm finally done. X minus 2, change the sign of the 2, quantity squared, plus x minus 2 quantity squared plus y minus 1 quantity squared equals 5 squared. Now, the video's done. That's it for today. Actually, this problem took about 20 minutes instead of 10, but I told you it was a doozy of a problem. You'll have one of these in your homework, and I might give you one a test or quiz because it really covers so much awesome material. You really need to think about so many things that I've taught you in the past, okay? So let's quickly review. If I ask you to write the equation of a circle, and I give you 3 points, 1, 2, 3, that lie in a circle, step 1, you don't have to graph, but it does help too. You might want to graph them, draw a triangle. Step 1, find the midpoint of one side, find the midpoint of another side, using this formula right here. Okay, step 2, find the slope of this side, find the slope of this side, using this formula here. Next, write the linear equation of your 2 perpendicular bisectors. Okay, we should know how to write linear equations. Next, once you have your 2 linear equations like we did here and here, then put them together and find their point of intersection. The point of intersection is your center of your circle. There's your point of intersection. It's your center. Well, students, once you know your center, you know the radius is going to be from the center to one of your vertices of your triangle. I don't care if you find this distance or this distance here or this distance here. They're all going to be the same. That'd be a good way to check your answer on a test or a quiz. Find this distance here, find this distance here, find this distance here, and you should get the same number out. That's a good way to check your answer, okay? Then, once you have your center, once you have your distance, that's your radius, so you have your center, you have your radius, so then you draw or write your circular equation. Hope this video's been a help to you. I hope you're understanding this math. Rewatch this problem if you need to. If you have any questions, never hesitate